All right, the timer started. It's officially time to get going. So thanks for coming. My name is Darren House. I'm a solutions architect at AWS, and I'm here to talk to you about centralized SOC operations on AWS. This is something that you don't often hear about, how to do SOC architectures in the cloud. A lot of times it's the on-premise world. You're familiar with the on-premise SOC environment, and then maybe you'll lift and shift some stuff up into the cloud. But what I want to talk to you about is exploring a little bit about some of the power and the capabilities of what you can do in AWS as it relates to SOC technologies and functions and different roles and what the roles can do within AWS. So before we dive in too much, I just want to make sure these two sessions here, so the bottom one, aligning the Nist Cybersecurity Framework, unfortunately that one happened over here about 2 hours ago, but if you can see the video, I would highly recommend it because in my opinion, whenever you think about security, you should always think about the Cybersecurity Framework. It's a fantastic way to start thinking through how you're going to do security and manage your risk in your environment. The other one, the Beating Sophisticated Attackers by Tim Raines, this is going to be a fantastic one. It's tomorrow. It's focused on how you can use the concept of a kill chain or a cyber kill chain in your security strategy for maintaining security and improving security in your environment. And one of the reasons why I'm a big fan of this is because part of this conversation here is going to be focused on the MITRE ATT&CK framework, which is heavily dependent on the concept of kill chain. How many people here are familiar with that concept of kill chain? So I can make sure, okay, we got a good, awesome, I like it. Okay, so I highly recommend, that's tomorrow. I think it's late afternoon or early afternoon, but I recommend you go look at it. So the main thing we're going to talk about here is up on the top point. This is the reason why we're here. How we're going to use MITRE ATT&CK and the tactics and techniques from MITRE ATT&CK to build out a capability using guard duty as the driver of events and mapping guard duty finding types to the indicators of compromise that are presented from MITRE ATT&CK on their website that provides a whole bunch of information about indicators of compromise, how you can detect certain things, all that stuff. So that's really the high level of what we're going to do. And I'm going to try and get through these slides as quickly as possible, and then I'm going to jump into a demo. And my goal is to be in the console as much as possible because I really want to show you what I think is an amazing set of tools that you have at your disposal that you might not be aware of. But in addition to that, we're going to baseline what SOC is. We're going to talk about how we can centralize data and how we can visualize that centralized data to detect incidents and to protect your environment. And then lastly, we're going to talk about providing event-driven automation for responding to that, primarily through the mechanism I just identified using guard duty. There's many different ways you can do it, but guard duty seems to be a perfect example of how you can start building out that approach to managing security and managing risk in your environment through guard duty and MITRE ATT&CK. So we can't really talk about SOC or security or anything like that unless you have an understanding of what AWS provides. And so we're going to do a quick mapping out of the different types of services and how they align to the Nist Cybersecurity Framework. So when it comes to identification, we identify the primary services that AWS provides for identifying what assets are out there and understanding what assets you have under risk that you need to manage and figure out what those threats are is going to be Systems Manager and Config. So for us, we're going to be using Systems Manager quite a bit in the demo to get information about files that are stored on instances, on a fleet of instances that might be indicators of compromise, or directories that could be exfiltration directories. We're also going to be talking about registry hacks that could be done for running, putting things in your registry, and we can search on those instances to look for some indicators of known registry hacks in your environment to get additional information as you're trying to identify the risks in your environment, what's going on. So Protect, we have a whole bunch of services in Protect. I'm not going to go through every single one of them, but from firewalls to VPCs to do the isolation. There's a lot of capabilities that AWS provides in the protection realm for the cybersecurity framework. For detection, there's a number of capabilities as well. So we have Guard Duty, we have Macy, we have Inspector, and we have Security Hub, which is up there, which is still in preview. It's supposed to go GA sometime soon, but that's going to be a centralized place for aggregating Macy, guard duty, and inspector data into one place so you have dashboards and visibility into what's happening in your environment. And so it's going to be a really cool tool. For this demo, guard duty is going to be the key thing for the event-driven automation. You have a finding type that causes an event to happen. And then the question of how do you do detection, response, and there's a mix of a life cycle here of how you investigate and how can you automate the investigation to make things a little bit easier for you. We all know that there's issues with having enough skilled cyber professionals. The work is out there. There's tons of work to be done. There's just not a lot of people that are capable of getting that work done. And it's a known issue. I think the latest numbers we have from the federal government was 299,000 open recs, something like that. So it's a big deal. So how we can automate the investigation and help the investigation, maybe to help reduce some of the false positives, maybe help your tier 1 SOC analysts relieve the burden for them, so stuff like that. And then to recover from major incidents, that kind of stuff. So AWS has a broad portfolio of these services that align to the cybersecurity framework that you can use in your environments to help you. So we've got that. Let's start talking about what SOC is. Okay, so Security Operations Center. There's essentially 3 functions that are provided within a Security Operations Center. This is going to be high level. You could have hours and hours conversation about this. And I think it was MITRE that actually wrote a document a couple of years ago about SOC operations, and it was about 768 pages, I think. So there's definitely a lot of information in terms of what SOC is. We're definitely not going to get into all those details, but at the base level, there's monitoring. You have to know what data you have in your environment, and you have to know what sensors you're using to pull data in, and then what the perspective is of the sensors that you have. And one of the demos, I'll show you a little bit more about what I mean by what perspectives you have, right? Because there's different perspectives you can have from similar data, whether it's from a VPC flow log or from an instance log, like a event log from a Windows system. If you can correlate that information in a single dashboard, it can give you a little bit more information. If you can do that in an automated fashion, that provides quite a bit of help there for you. So monitoring is one of the key functions within a SOC. And then the next one, there we go, is detection. So you get data coming in, but then you have to know, okay, what is good behavior? What is bad behavior? How can I detect it? What are the parameters that define good behavior versus bad? So that's the second key functionality of a SOC, and we're going to be providing some capabilities here for that as well. And then lastly, the response. So you get the data in, you define your parameters for what is good and what is bad, but then you have to decide if you see bad behavior, what are you going to do about it? Oftentimes that's going to be a run book, a playbook kind of thing, but there's a lot of different ways to go about your response. So these are the 3 key functions within a SOC environment. Now, who does this? So first we have the tier 1 analyst, right? So this is the person that's going to be looking at the monitoring, looking at all the alerts coming in and trying to figure out what's a false positive and what's a true positive. All right, so these are the people that oftentimes get super overwhelmed because there are so many false positives out there. And by the people that raise their hands, I'm not telling you anything you don't know, right? So I'll just go on to the next one here. So the tier 2 responder, that's the next type. So the tier 2 person is the one that will take the information from the tier 1, and if it is actually an incident, if it is something that you need to investigate, then they can start doing the investigation and do some of the response for it, depending on the severity, depending on the level, right? But then you might have the tier 3 responder, who is a deep technical expert, a subject matter expert, somebody who can do significantly more work than the tier 2 operator can do. Oftentimes these are the ones that build tools for a team, or they actually start threat hunting programs for a team. And one thing I'm going to talk to you about and show you is the model that we have here for SOC on AWS using the services that we'll get to in a few moments. It gives you a pathway to start thinking about how you can do threat hunting, and I'm not going to say that this is going to get you threat hunting, because that's a complex conversation and it takes a lot of skill sets, but it's a good idea to start thinking about how you can proactively look at threats and automate the looking of threats, and then making it so that your operations becomes a little bit easier. And hopefully through this conversation, we'll be able to help tie all these pieces together and show you how we can do that with CloudWatch logs, CloudWatch log insights, and then CloudWatch dashboards as the means to do that. So we got the SOC out of the way. Now there's a different ways to centralize your data, to aggregate your data. And this right here is a representation of a solution that we have that we built for CDM, right? Or the FISMA CIO dashboard, an agency level dashboard, a way to aggregate data, centralize that data, and then provide it in a quick site for the dashboard. So on the left-hand side, you have all your sensor information. You can do it a multi-count, multi-region for a majority of these. And if you look over here, the bottom 3 lines are going to this S3 bucket. And then you see the top 2 lines are going to a CloudWatch scheduled event. There's a reason for that. The bottom 3, they are configurable to be multi-count, multi-region. All you have to do is make a couple configurations and then it's done, and the multi-count, multi-region capability is there. For services like GuardDuty, you have the ability to do multi-account, but you can't do multi-region today out of the service itself. And then with Inspector, you can do single account, single region. So what we did with this architecture is we used Lambda to be able to query those services for the data that we needed for the FISMA CIO dashboard requirements, and then aggregate them into that centralized S3 bucket, normalize that data, and then create these what's called manifest files so that the QuickSight service could ingest that data and then provide a visualization for a dashboard that meets the CDM and the FISMA CIO dashboard requirements. So this is one model. This is more of a historical model, right? But there's also the real-time or near real-time model for dashboards, and that's what we're going to get into with the demo as well, right? But this is a working architecture that we have. So, and this is just to identify. It's important to understand the multi-region, multi-account capabilities within AWS, and those capabilities are growing. It's a trend within AWS to make our services more multi-account, multi-regional, make them easier to configure that way versus having to use Lambda functions to aggregate data, that kind of stuff. But today, this is how it all looks. There's a good majority of them that can do multi-account. The ones that can't do multi-region today, for the most part, you can use Lambda functions or step functions integrated with Lambda functions to do that. But in addition, for the CloudWatch logs, to be able to do multi-region, you can ingest those into Kinesis, for example. You can take those from Kinesis and then you can put them into an S3 bucket, a multi-account, multi-region. So there's multiple steps to go through, but you can get to that multi-account, multi-region today. Okay, now we're getting to the fun stuff. So MITRE ATT&CK. So what is this? So MITRE ATT&CK is a globally accessible repository and knowledge base of tactics, techniques, indicators of compromise, tools that attackers use to attack your environments. All right, so it's a very comprehensive environment, and this right here shows a small subset of what all of MITRE ATT&CK has, right? So it goes across from initial access, and that goes to the kill chain conversation, right? But it fills a lot of voids that we currently have in security in terms of trying to understand how secure are we, and what is the roadmap that we need to follow to get more secure, and give you a path to follow. And so what we're going to talk about in this design and this architecture is how to take the data that's already there. You're leveraging an asset that already exists today and it's free to everybody. How can you leverage this to make your environment more secure and do it in an automated way? So we're going to go through 2 scenarios, all right, and we're going to run the architecture through these 2 scenarios. So the first scenario is going to be APT18. The second scenario is going to be Leviathan. So these are 2 threat actors that are known threat actors in the world, and they've had some attacks as late as 2018. So last year there had been some attacks that people attributed to them. We can all talk about attribution, but the reason why I picked these 2 primarily is because both of these focus on government. So these guys are the ones that are looking at your networks, trying to get into your environments, okay? They also follow some common patterns, right? So how do you do things? One of the patterns is once you get a compromise, you have to persist your access. So they do registry hacks, and they put files in place to try and maintain that persistence. Another thing they do is for staging exfiltration, they'll use specific folders. Sometimes they change, but there's some known patterns there for aggregating all the data that they found before they exfiltrate it out. They also use passing the hash as a way to move between systems and compromise credentials. And then lastly, PowerShell. So PowerShell is a big thing. Most admins use PowerShell on a regular basis in your environment. So the attackers end up wanting to live off the land, and they can use PowerShell to move around. They can use PowerShell to download things like Cobalt Strike or like Mimikatz, for example, and try and obfuscate the ability for you to detect a lot of this stuff. So the goal here is we're going to go through each one of these scenarios, and we're going to jump into a demo and show you kind of how the system works and how we're thinking about doing SOC in AWS today. So let's start with APT18. So the indicators of compromise that we have from APT18, according to MITRE, are the registry key, the run entry within the registry keys. And oftentimes they can use folders like HID Manager, RASCON, Track Server. Those areas are some known areas where APT18 will end up creating these folders or using folders to store data before they exfiltrate it. So they'll use registries. They also use a tool called GhostRat, a remote access tool that can often be used for lateral movement between systems and between hosts. And that often ends up using like remote shell, which is, it'll be TCP port 514 or 513 in your environment, usually. It can be multiple different ports, but those are the common ones. So we'll show you ways that you can look through those ports and look through your environment in an automated fashion to identify what's going on in your environment. And with that, oh, one more part. I gotta lay out the whole architecture for you. It's kind of important. So I'm going to lay out how this is going to work, and then we'll go into the demo and I'll show you it, okay? So the first thing we have, a guard duty finding. So it's a guard duty finding behavior, EC2, network port unusual. What that means is guard duty sets a baseline of normal behavior. If they see something if guard duty sees something that happens outside of that normal profile behavior, it will make an alert. So guard duty will create this alert. It'll send that finding. All your guard duty information goes into CloudWatch, and you can create what's called a CloudWatch event to capture all your guard duty information, and then you can use step functions or a Lambda function to parse out information from there. So what we're going to be parsing out for our demo right now is the network port unusual finding type, because we know that APT18, some of the indicators of compromise would lead to this type of a finding. So we've created a Dynamo database that has these findings, but it also has information about certain queries for different services that gather data that you can query to pull some of this information in. It also will, actually, I'll just move it along. So we're going to be querying CloudTrail logs, for example, because one of the things, if you get a compromise on an instance, one of the first things oftentimes an attacker will do is it'll try and do a list profiles or figure out what the instance profile has, what permissions it has, to see if it can get more, if it can create anything, if it can get more permissions. So we're going to do a CloudTrail query to look for any API calls from that instance with that instance role that's coming from that source to see is that an indicator, is this a false positive or is it a true positive? We're also going to be looking at the VPC flow logs, looking for indicators of compromise for a remote access tool for GhostRat, ports 514, port 513. We're also going to be going into Systems Manager. So Systems Manager has a whole lot of information that you can get about your EC2 instance in your environment. So we're going to be querying Systems Manager, and for this we don't use CloudWatch log insight queries, we use Lambda functions to pull out some pieces of information based on these indicators of compromise that we know exist based on what MITRE ATT&CK has identified for us. So for this, it'll be looking at the registry keys, and it'll be looking at the files. And then after that, we're going to end up doing a notification, basically saying, hey, we did a query, your dashboard's ready, and it's going to create a dynamic dashboard based on the results of the query that you had, and it's going to populate that within CloudWatch logs or within the CloudWatch dashboard environment. Okay, so that's how that looks, and may the demo gods be good with us, because we're going in. All right, so going to the demo. Awesome. Okay, so let's start out with guard duty. So this is where it all starts. If you notice right here, it's the behavior network port unusual. I'm just filtering on that so you can see that that's what we're looking at here. And this is an example. So I want you to see an example of what the findings look like and some information. And there's some key pieces here to it. I'm going to scroll down. So for example, the instance profile. This information is in the guard duty findings, so you can take that information, you can pass it on to your query to look for stuff for the instance to see if that instance is actually sending or trying to escalate privileges in your environment, right? So guard duty, the finding type has a lot of valuable information that you can pass into other systems or use to query other systems. So we show the event finding. I'm not going to go to CloudWatch events because it's a fairly simple process, but I'm going to jump into the dashboard. I'm sorry, the Dynamo table. So we have a dashboard that's set up, and I'm going to jump right here and give you a couple of examples. So this one right here, actually let me go down to network port unusual. So we'll give you an example of the get instance profile. So that's one of the calls that an adversary could use to try and see what's going on. And I know it might be a little hard to see, apologize for that, but it's identifying the source. So the source is a CloudWatch log group. So, and then the CloudWatch SOC Ops Cloud Trail. So it's searching the Cloud Trail logs that are being centralized and aggregated, as you saw from the former diagram, right? It's gathering all that information, and this is the query language that's being used to get the event name, the event source, the user identity, ARN, some other piece of information that it's going to parse. It's going to pull that information in, and then it's going to pass it along to CloudWatch dashboards. And so for this demo, we have network port unusual. We have 1, 2, 3, ghost rat, instance info, registry keys, VPC flow logs. So there's a number of different parts in the table that are going to be used as we aggregate all this data and put it into a dashboard for you. So then we go to CloudWatch. So this is CloudWatch log insights. And I'm going to show you this real quick because I think it's important for you to understand that you can do all this manually. And oftentimes people do things manually. You know, when you're on premise, it just becomes a little more difficult sometimes to automate. So I'm going to walk through the process of doing some of this manually so you can see the data that comes back, kind of understand that flow, and then I'm going to show you how much different it is when you automate it. Okay, so this one right here, we're doing SOC Ops. The query that we're doing, it's looking for Protocol 6 TCP, port 514, and right now we're looking at a day. That's what the 1 day, but this you can change the times anytime you want. But you run the query, looking for any information, and then one thing to note right down here, this part right here, while you're doing the query, it'll show you how many records matched, how much data and how many records it looked through, and it'll give you an indication of the performance and the time it took to go through all the data you have to get the results for that query. Okay, so it gives you some indications of the performance it's providing for you. So in this, in the last hour, we've had one instance where there was port 514 that was trying to get into your environment. Now, fortunately, that was a reject. So that's a good thing, and the reason why it was a reject is because it was coming from a public IP space, so it was being blocked by a security group. Okay? But what else can we look at? So there's, I'm going to copy this right over here, because there's different ways that you can look at things also. So let's take the same data and put it into a format like this, and then you can say, this might actually be even better data to look at because of the way the format is. So it gives you, it's more aggregated. It gives you source, destination, IP addresses, and the bytes transferred. It's a little bit more easy to look at, so you can say, is there actually any data going through here? Is there some exfiltration data or anything like that? What kind of traffic is there? There's not a lot, it's 40 bytes. So The other thing you can look at, we're talking about the CloudTrail logs, right? So we looked at those. So this right here is going to be the query that you can use in the CloudTrail logs from CloudWatch Log Insights to gather information. The event name, list instance profiles. That's the API call that's being made from the instance. You can get the, it's coming from the IAM, and then it's the instance profile that's being used on the instance. So you run the query, and this will end up identifying any instances there were for, so we have a couple of them here. And again, you can customize the date range for relative, so you can go from days to weeks. And just right here in the dashboard, you can modify your query results right here and figure out, is this something that's been going on for a while, or is it just happening right now? All that good stuff. Now, in addition to that, we have, we'll do the security logs. So pass the hash. So pass the hash is when you can get an NTLM hash of the password that somebody has, and you can take that and pass that in to get compromise other instances and move laterally between instances with a privilege escalation from the hash of like the admin or something like that. This is commonly used with Mimikatz. Mimikatz is one of those tools that's used often by the adversaries. So what we know is that there's common patterns from the event logs, and these are from the Windows security event logs. But there's common patterns in these event logs that can identify when pass the hash is happening, right? And so that's why we're looking for this stuff. So we're looking for certain event types. The event type of 4624 with a logon type of 9, and then the, yeah. So we run this query, and then you can see right here, if you see event ID of 26 or 4624 with this logon type and that logon process name, that is conclusive evidence that that is a pass the hash happening in your environment. So you know right then and there, you've detected bad behavior, and you can send that to your tier 2 or your tier 3 SOC operator, depending on what your processes are. All right, so like I was saying, you can do all this stuff manually. It'll take a while, but you can do it. In addition, we have Systems Manager. So we looked at the logs. We have VPC flow logs. We have CloudTrail logs. We're looking at instance logs for security events. We also have some sysmon logs. We have some PowerShell logs we're going to be looking at. So we're aggregating all this log data. We have some Linux instances, so we're getting var log messages. We're getting the secure logs. We're getting Nginx logs. So we're gathering all kinds of logs, and you can search across these different log streams to look for information, indicators of compromise. Now, when it comes to Systems Manager, this is not going to be query language. This is going to be doing some API calls through Lambda to gather information about those services to see if there's indicators of compromise in that environment. So what you'll see right here is, I'll point you here. So this shows that I have 20 instances in my environment right now. And I'll scroll down just to show you the instances that I have. There's a whole bunch of them here. There's these guys. There's a whole nother page of them right over here. And what the API call will essentially be doing is what I'm going to do manually for you right now. So let's say we're looking for a file. So go to File and the file name, and we'll call it equal. And this one is going to be badguy.exe, because bad guys always like to show themselves in plain sight. But if you're searching for a file, what that did is it searched through all the 20 instances that were there. It searched through the data that it was looking for to see, is there an indicator that you know of that could show a compromise on your instance? And it looks like there is. We have one instance right here that caught in that. So we scroll down and we can get the instance information. We can go right to that instance, and there you go. So the other things we can do is just to show you, we're going through these APT 18 things. So track server. So let's copy this bad boy. So now we're going to do file, and we can do install directory. Let's say begin with. And it looks like there's 2 instances in our environment that have these indicators of a compromise, because these directories are oftentimes used to exfiltrate data. So again, this is just searching across your environment You don't have to manage any servers to do this. You didn't have to manage any large fleets or anything like that. This is all stuff that comes out of the systems manager service itself. So these are some. Let me do one more for you. So we'll do registry value name, begin with, and I hope I get the name right, because if not, oh, good, I got it right. So this is also can be an indicator of compromise, having this in there as well. So we'll go down here again, and what you can do with these, you can click on this, it'll bring you up to the inventory page for that instance. You can look in the inventory, and then you can start looking through all the different pieces of data that Systems Manager has for this environment. And this is a lot of data, right? So we'll end up looking at the registry, and then you can scroll down, and there you go. So you see your stuff right there. So these are the things that it's querying to get information, and then the end result is it's going to be populated into a dashboard. Right? So right now what we're looking at is the CloudWatch dashboard environment itself. And you can see that I have just a SOC dashboard, just one single dashboard in there, and yours can look however you want it to. Right now mine has a couple different pieces in it. It's going to look for denied access from CloudTrail, just to keep information on that. It's going to be looking for understanding which APIs are calling, how many APIs are calling things in my environment, different statistics for it, error codes, all that kind of stuff, right? You can do lots of different types of dashboards based on the information that's important to you. But just want to show there's just one dashboard right there. So now what I'm going to do is we have a script that we wrote for demo purposes to make it a little bit easier for you. And yeah, it's pretty much impossible to see. I apologize for that. But it's a JSON file, and all it's doing is it's going to send that guard duty finding that we talked about at the beginning. And it's going to send that finding type with the instance ID as part of that finding into the Lambda function that's going to query the Dynamo table. It's going to find those 5 or 6 entries in the Dynamo table. It's going to pull the CloudWatch log insight queries and query the CloudWatch log insights. It's also going to query Systems Manager. It's going to pull all that information together into a single dashboard right before your very eyes. So, and we got 200 SAS codes, so that's good for me. Demo gods have been good so far. And let me just refresh the page. And now look, we have a dashboard right here. So we click on that dashboard, and you can adjust the formatting how you like. We do this in the Dynamo table right now, but these are some things you can do, and I've mapped them to the MITRE IDs. So remote access, a T1133 and 1059, for example, or remote access for MITRE. So this is looking for flows. Now you see this is a 3-hour window right here. So that's why you might not show everything. So it depends on the time frame that you're looking for. But one of the great things is you can adjust this, right? So when you're looking through here, you can see that I don't have anything in here for that, but I do have some indicators on my instances that make me wonder if something's going on. In addition, it looks like I have some CloudTrail entries where my instance is trying to find out what data it has or what profile it has, and trying to get an understanding of what permissions that profile has. So to me, this is enough of an information to say we need to look a little bit further into this, and so you can pass this on to your Tier 2 SOC operations. You can look down here and query, or just look even more, and luckily, so for this, they're trying to do list profiles, but we use least privilege, so luckily they got denied and they couldn't do that. The other thing to know is, like I said, you can change the time frames right here, and then you'll end up seeing a little bit different information based on those time frames. So now we're getting some 514 traffic that we're seeing in there. So this all aggregates the data together so you can look at it from a single place, and then when you're done with your figuring out whether or not it's a true positive or a false positive, you just delete the dashboard, or you can keep it there. It's up to you. All right, so that's one way you can do it. The other thing to note that I think is really cool and really powerful is this part right here. So the 1060 and the 1060-1083, these are the stuff they query from Systems Manager. But CloudWatch Dashboards has this capability of doing a text widget. So these are text widgets versus the log widgets of the other ones from the VPC flow logs and all that. The text widget has this capability of doing markdown language inside of that text widget. So what that really means is that you can query anything in AWS. And then you can populate it on a dashboard. All right, so that's powerful. Any services that you have, if you want to query stuff to find indicators, you can do it. You can do it for your RDS instances, you can do it for your S3 buckets, you can do it for your EMR clusters. If you can query it, which you can, everything in API, you can pull that text, put it into the markdown language. You have some options for formatting, right? There's some table formatting and there's some bullets for formatting, that kind of stuff. But that becomes a very powerful tool. And you can also do things like have a click to search, and this is going to take you to Systems Manager so you can start doing the search we did before to get some more information, right? All right, so now we're going to put back to the dashboard. So we have two dashboards, and I'll go back to the slides, please. Awesome, okay. So the next one is going to be the Leviathan. There's going to be some similarities, some differences. They have some common things about using folders, but this one they also are known to use pass the hash. They're known to use things like Mimikatz or Cobalt Strike for download tools, for example. They use PowerShell extensively, living off the land, to try and obfuscate what they're doing and make it look like it's normal admins that are doing things. So these are the indicators of compromise that MITRE provides for us. And we didn't have to do anything to get these. MITRE did all the work, and they're continuing to evolve this work and grow this portfolio of knowledge for all of us to be able to use to improve our security environment. So this one again, the only difference really with this diagram is going to be two things. First is going to be that it's just a different finding type, right? So you have the backdoor CNC activity. So what that says is that GuardDuty identified that the traffic that you have going through your environment is communicating with a known command and control server. So be aware, right? So it has threat intelligence capabilities. We get intelligence feeds. We have whitelists and blacklists. We understand the good and bad IPs that are out there. So it's a known C2 IP, and then it'll give you a finding. So this can also often be mapped to Leviathan and many, many others, actually. So Leviathan's not the only one. But you'll have the GuardDuty finding type that will go to the CloudWatch, that will use the CloudWatch event to send it to a step function, which will use Lambda to query the Dynamo table, which will have, I think there's 7 or 8 of them, so there's a few more on this use case versus the other one. Now, the big difference with this one is that it's also going to end up querying the instances with CloudWatch, right? So up there, we're going to query the PowerShell security, the PowerShell logs. We're going to query the Windows security logs, and we're going to query the sysmon logs to give you a little bit of different perspective. And you'll see in a moment when I talk about perspective of what you can see from the VPC flow logs for a remote shell. To get remote access versus what you see in sysmon, and the ability to identify the differences between the two gives you extra information. And then we're going to query Systems Manager for the indicators of the files and registry. And then we're going to do the same stuff, right? So back to the demo, please. We got the demo? So I guess they're smart. They know everybody wants to go and have beer now, and I'm making you guys wait for an extra 10 minutes, so I apologize, but I think this stuff is cool. I hope you do too. All right, so this one is the Leviathan one. So it's just a script, like I said, that's going to send the GuardDuty finding information with a different GuardDuty finding type that's going to get sent into the environment. And so we got a 200 again, so today must be my lucky day. So we're going to refresh this, and then what you'll see is that there's a Leviathan dashboard now. So we'll click on the Leviathan dashboard, and I'm going to just move this up to a day just to make it a little bit easier for us. And I might have to make it 3 days. Let's see. So here we have the same kind of information, the instance info. We have the debug information that there could be suspicious folders in there with a link to go to the SSM environment to do further investigation. So right now there's not showing any remote access on 514, but what it is showing on this one is sysmon logs. So you might not be seeing anything there, but what you're seeing here is you're clearly seeing an indication. So PowerShell has the ability to do PowerShell remoting. That means you can use PowerShell to remote control or remote access other systems and then be able to get information, be able to put information, be able to transfer files, be able to run scripts, all that stuff. So what this is showing is port 5985 is a PowerShell remoting port. So what you're seeing is that there is activity happening in your environment between two instances. This might be normal. It might not be normal. Right, so that depends on your policies, what you use. You know, at AWS, we often recommend that you shut down all that stuff and end up using a systems manager with our sessions manager. So you can shut down all your ports, and if you see anything going on, then you know that's a detection that's working because it's not supposed to be happening anyhow. There's a lot of different ways to do it, but just to show you that, the other thing is PowerShell logs. So this is querying the PowerShell logs, and it's doing a search for everything in the PowerShell logs for anything that says Mimikatz. It could be Cobalt, it could be any other indicator of compromise for an attacker who is trying to use PowerShell to download some persistence or some malware to continue on with their exploit, right? So they can use obfuscation as well, so they can encode it, but this is a way to identify that, and you can look into this. And then in addition, we have the credentials, so the pass the hash. It shows that there's been a whole bunch of instances with pass the hash. And we also have information about get instance profiles, all that stuff. So the EC2 instance clearly has an issue, and this definitely needs to be remediated, right? So all this information is brought to you automatically just by GuardDuty doing an event finding type. And it's a new way for you to think about how you do security in the cloud for your SOC environment, and having dashboards that are historical, like we showed earlier, or near real-time dashboards that are dynamic, based on what you're looking for, based on the indicators and all the information they have there. And I think I have one or two more slides. So can I go back to the slides and then we'll get you guys out of here. All right. Yeah, so yeah, I was going to go to the reporting, but we're just going to get you out of here because yeah, there we go. How about that? Thank you very much. I appreciate your time. Go enjoy the rest of your evening. Thank you.